Are you having a hard time writing maintainable code? Well, fear not, because today we are going to talk about the fourth solid principle, and that is interface segregation principle. And also, we are going to pick a lucky winner for my 60-minute Zoom call mentoring session. So if that's something you're interested in, go ahead and hit that subscribe button because it will help for you to show it on your home feed, and also for other developers, go ahead and hit that like button, and let's just jump right into Xcode. Interface segregation principle, the fourth principle in the solid principles. Before we dive into this, let me just remind you about Dev Factory. Dev Factory is a 16-minute Zoom call with me about SwiftUI, Swift, or your bugs. So go ahead and check out rebeloper.com/mentoring. And if you do want to win a free mentoring, go ahead and like this video, subscribe to the channel, share, hit that notification bell, and most importantly, comment down in the comment section below, and I will choose or pick a winner in the next video. And for the previous video, I will surely pick a winner at the end of this video, so make sure to check the whole video out, and you will see who the lucky winner for a free 60-minute Zoom session with me will be at the end of this video. So, interface segregation principle. What is actually interface segregation principle, and how could we use it? Well, interface segregation principle is the fourth in the solid principles. And what does that stand for? That is for building, avoiding bad architecture in our project, like fragility, immobility, and rigidity. Now, this principle establishes practices that lend to developing software with considerations for maintaining and extending as the project grows. So these principles, if are followed correctly, you will easily maintain your project and extend it. Now, here's the single responsibility principle, the open close principle, the list of substitution principle, and I have already created 3 separate videos on this. Go ahead and check out the link in the description for the whole playlist. Now, today we are going to take a look at the fourth one, interface segregation principle. A client should not be forced to implement an interface that it doesn't use. Now, here's a little bit of more explanation to that. Clients should not be forced to depend upon interfaces that they do not use. Also, in other words, no code should be forced to depend on methods it does not use. Now, this third one is kind of what I prefer as the explanation. It's really, really nice. So let's just jump right into Xcode and take a look at this with a before and after code example. With all of these, I'm always going with a before. Here was list of substitution principle, and after code. Now, the before and after is empty currently, but we are going to build that out today. Now, what will we build out today to kind of learn about the list of the interface segregation principle? Well, let's say that we have kind of these workers, and they can work, and they can eat, and optionally they can eat, and you will see why, because a human may eat but a robot may not eat. It doesn't need eating schedules or so to that say. So let's just build this out like you would normally if you don't understand this principle, the fourth principle, the interface segregation principle. So let's just create this. And by the way, if you haven't checked out the playlist, there is a link in the description for the whole resources, and once you download the resources, you will find that these are just simple folders with the before and after Swift file. I highly recommend that. Go ahead and check that out, because I do have kind of this comments there, so you can follow along. Okay, so before, let's jump right into the code. Show me the code. So let's just have a file private protocol. And by the way, if you don't know what protocols are, or you need a reminder on that, go ahead and check out also the link in the description. I have an awesome video about protocols. So let's create a worker right over here. And this worker has to work, and it also has to eat. Okay, so that's our simple protocol. Now let's create a human, file private class, and I'm making this file private so it doesn't interfere with all the other sessions that we had. So let's create a class and also the after file. So class human, and that would be, of course, a worker. And let's wait here. So Xcode complains still, it complains. We are going to have more room here, and let's just fix this. And let's just print out working and then eating. That's fine. So now all of the two functions that we must adhere to are there, and a human can work. Now, if we create an example, again, a file private func example here, and let's create a human. Let me just have more space here. So let human, and that will be a human. There we go. And then we would just go human dot eat, and that would just print out prints working. Sorry, not eat. Let's just start with work. So that would be the first. Let's just start with work. It's just going to print out working. And likewise, as you'd expected, human eat, and that prints out eating. There we go, eating. Okay, so this is a no-brainer. You knew this, and that is fine. But what if we want to create another worker, which is a robot? Okay, so let's do that right over here. So we just go file private class, there we go, and robot of type worker. So, of course, because it must adhere to the worker protocol, we want to add all of these. And now we have a problem because, okay, if it's working, then that's fine. We just print out working. But what happens if we eat, but the robot doesn't have to eat? So usually you just do like fatal error with a message of robot does not eat, or something like that. Okay, now this is not that good, because you have a fatal error in your code. Or even if you don't have a fatal error that will crash your code if it's ever going to be executed, you have a function that if it's going to be executed, it shouldn't be executed. I repeat that. You have a function that if it's going to be executed, it shouldn't be able to be executed. Okay, so here's what I mean. Let's create our robot, and that equals to our robot. And then we just go robot.work, and then robot.eat. And this works fine. So if we hit Command B, the code compiles. Okay, so we want to register our device, but what I will do is just select iPhone 13 here, and let's hit Command B again. So this will actually compile just fine. As you can see, build has succeeded, really nice. And there's a bug in here. There's a fatal error that should not occur at all. So this will print out, if this will execute, this will print out working, but this will actually crash your app, which is not that good. So how to fix this? Well, here comes interface segregation principle, meaning that no code should be forced to depend on methods it does not use. And this robot is forced to use the eat function, but it does not use it. So that breaks this principle. So let's build this out with this principle in mind in the after file, and let's see how this should be written out, knowing now that the robot does not eat. So it should not use the eat method. So how would we do that? Let's create two protocols right now. So file private protocol, there we go. and we are going to create a workable. Yeah, and go ahead and check out the link in the description for the protocols. So you know why workable is a really great name for our protocol. And let's just create a func and work. And then we are going to create another file private protocol, and that is feedable. How awesome is that? Feedable, and we just go func and eat. Okay, so now these are separate protocols that we can use. So let's create our human file private, a class, and human. And now the human will be workable, as you can see, and feedable. Now you're kind of getting this already. So let's just have our protocols stubs added right over there, and we just go print and then working, and also for our eat and eating. There we go. Okay, so finally, let's take a look at the most trickiest one that we had so far, and that is our robot. So let's create our class here, which will be called robot. And now the robot will be workable, but it will definitely not be feedable because it does not eat. So now if we add the protocol stubs, you will see that there's only one protocol function to adhere to, and that is work. And then we are just going to print out working. And this is how it should be. Now, the robot class does not require an eat function. So let's just go and create our example. Let's see, file private, func example. And let's create our human. Well, actually, I'm just going to copy out the human from the other file because it's the same thing. Let me just move back. And yeah, it's just going to do the same thing, exactly what we wanted to. Now let's create our robot, and that's a robot. Now, if we type out robot and hit a dot here, you will see that the only option we have here is work. And basically that's it. If we try to add robot.eat, of course we don't have auto-completion, but even if we added it, if we type that out, we will have a compile type error. As you can see, value robot has no member eat. And this is clean code. This is how it should be done. This is interface segregation in action. Now, basically that's it. Let's just comment this out. If you do like these types of videos, go ahead and check out rebeloper.com/mentoring, where you can have a 60-minute Zoom call with me where I can teach about all of this, about Swift UI. But as I mentioned at the beginning of this video, we will pick a lucky winner that can have a 60-minute Zoom session with me from whatever they want to talk about. And that winner will be picked from our previous YouTube video. Therefore, go ahead and like this video, subscribe to the channel, hit that notification bell. Yeah, I did say like it, and comment down below, because I'm going to now take one comment from this video. So first of all, let's take out our link from the previous video and just paste it right over here and just grab one lucky winner. So let's go fetch. Let's just continue. And there we go. Let's pick a winner right now. So there we go, is Jalal Najafi. I hope that I spelled out your name correctly. And his comment was, "It's great and I need to talk with you." So I will meet you in a 60-minute Zoom call. Go ahead and contact me at support.rebeloper.com with your email that you have made your comment with. This is really important, so I know that it's actually you. And we will take it from there. And yeah, you will meet me on a 60-minute free Zoom call. Okay, otherwise it's at rebeloper.com/mentoring. Now, if you do want to be the next lucky winner to win a 60 minutes free Zoom call with me, go ahead. And this is what you have to do. First of all, you want to like this video, then subscribe to the channel, hit that notification bell to get notified of new videos, and share it with your developer friends. It helps quite a lot. And then finally, and the most important part, go ahead and comment down below in the comment section so you may have a chance to be picked in the draw in the next video. Now, if you do like these types of videos, go ahead and check these out. Here is the next one, and that is about dependency injection principle. And here you can see the whole playlist for our solid principles. And as usual, I will see you in the next one.